So this is going to be 34-2, and we're going to take a look at the DI here. So let's start with number 1. It says y equals the sine of 3x. Now because we have this value right here, 3, that's in front of my x, immediately I should recognize and be able to say, okay, right there's going to be a period change. So that means is that these original 5 values, 0, pi halves, pi, 3 pi halves, and 2 pi, all of these are going to change. So what I need to do to find what those new values are, you take whatever it is here and you set that between 0 and 2 pi. Now the reason why it's 0 and 2 pi is it's between 0 and the original period. And we learned that the period for sine and cosine, the original period is 2 pi. Now for tangent, it's going to change. The tangent, the original period, is pi. But now I need to solve for x. So I divide everything by 3, and so I get 0 is less than or equal to x, which is less than or equal to 2 pi thirds. Now I have to create that new box. And so for that new box, this is still 0, this is still 2 pi thirds. And so now to find the middle value, we add the two ends and divide by 2. That's how to find the middle of anything. So this is going to give me 2 pi 6 or pi thirds. For this one, to find the middle value, add the ends, divide by 2. So 0 plus pi thirds divided by 2. That's going to give me pi 6. Now if you notice there's kind of a pattern here. I could say that this value here is the same as 4 pi 6. Now if you notice, it's counting up by pi 6. So 0, pi 6, 2 pi 6. So this would be 3 pi 6. Yep, I can write that as pi halves, but just know that in terms of scaling my graph, it might be easier for me to leave it in terms of pi 6. So for my graph here, I can now say that this is 0, pi 6, 2 pi 6, 3 pi 6, and 4 pi 6. So now graphing this for sine, we know that it's going to start at the center line. It's going to go up to the amplitude, in this case, which is 1. Then it's going to cross the center line again, then it's going to go down to the amplitude, which is -1, and it's going to go back to where it started. And that's going to be 1 cycle. Now to find all the other information, it's saying graph 1 cycle, state the domain, range, and period. So my domain is going to be from -infinity to +infinity. My range, it's the amplitudes, so that's going to be from -1 to +1. And now the period, to find the period, we said that we can use the equation 2 pi over b, and so that's going to be 2 pi, and then my b in this instance was this 3, so 2 pi over 3. Now to also find the period, I could also say in this value box, it's the last value minus the first. So in this instance, it's going to be 2 pi thirds minus 0. Well, 2 pi thirds minus 0 is also 2 pi thirds. So those are the two ways that we can find the period there. Next one. So for number 3, y equals -4 tangent x over 2. So I'm just going to set ourselves up for this one, and then you can go ahead and finish it because we understand, the way that tangent works, right? The parent graph for tangent, dot, asymptote, dot, and it normally is going to do something like this. But remember, because of that reflection here, it's going to go down that way and go up that way. So it's going to be the red dotted version because it gets reflected. Normally, my period is pi, right? And we said normally in that value box, it's going to be 0, pi halves, and pi. But because of this value here modifying x, my period's going to change. So I take this x over 2 and I put that between 0 and the original period for tangent, which is pi. Now solving for x, so I multiply everything by 2. I get 0 is less than or equal to x, which is less than or equal to 2 pi. So I can create my new value box. 0, 2 pi, add these together, divide by 2, you just get pi. Remember, dot, asymptote, dot. And then those are going to be the new values that we have to label. And we can go through dot, asymptote, dot when we draw our one cycle for tangent. You may have to, after you draw that cycle, you may have to continue drawing it, because remember, that pi, we have that period for the, for the domain, we're going to have an issue because we have an asymptote. So you may have to kind of extend it out in both directions to kind of figure out how am I going to write out the domain. So it says, the next one, it says, verify the identity by graphing the right and the left sides on a calculator using Desmos. So what you're going to do here for number 5 is you're going to plug the left side in. And then you're going to plug the right side. And what should happen is both lines should be the same. Both graphs or lines, because that's what it's going to end up being, will be the same. Or at least show that they're going to be the same. Okay, next one. So for number 7, x squared minus y squared equals 1. It says determine whether or not the equation represents y as a function of x. For us to determine it analytically, which is in this instance, we're solving for it, we have to make sure that once y is by itself, right, it can't equal two different values, meaning it can't be a plus and it can't be a minus. So I have to get y by itself. Now in this process of getting y by itself, right, divided everything by negative. When I take the square root here, I'm going to get plus or minus the square root of negative 1 plus x squared. Well, that's my issue. Right here, my y equals two different values. Well, my y can't equal two different values for a given x that I plug in. Right? There only can be one, for one x, there can only be one y value, so therefore it's not a function. Number 8. So it says use the given information f to find and simplify the following. So I'll pick a few of these. So if I have f of x equaling 3x minus 4, well, f of 3 means I plug in 3 in for x, and you simplify that. If I have f of 4x, that means that where my x is, you replace it with 4x. Right? Instead of x, it now becomes 4x. If I had, and then you simplify that. If I had 4 f of x, that means you take 4 and you multiply it by what your f of x is. We said f of x is 3x minus 4, so 3x minus 4. We have f of, we'll do x minus 4. Well, that means you take your function, so 3x minus 4, and then you subtract an extra 4. And then you simplify it. Well, but that one's already simplified. So let's move on. So it says let that function be this piecewise function. Now remember, when we're interpreting this piecewise function, it's saying this graph exists when x is less than or equal to -3. This graph exists when x is between -3 and +3, not including -3. And this graph exists when x is greater than 3, but not including it. So depending on where my value of x is, right, it's going to tell me which one of these graphs I need to correspond it to. So on number 10, it says f of -3. So I need to look at, where does f of -3 exist? Well, it doesn't exist here because it has to be greater than 3. Maybe here, but because it does say -3, but it can't include it. Here it says x is less than or equal to -3, so this is the graph that I use. So that means that I have to plug in -3 into my function, which is going to be 2. If I say number 11, f of 2, well, 2 exists between -3 and +3, so this is the function that I use. And so it's going to be the square root of 9 minus 2 squared, which is the square root of 5.